Today we're looking at the inverses of matrices, and using those inverses to solve for systems of equations will come next. So if we look at the inverse, or the formula of an inverse, so let's start with the 2 by 2. The formula for my inverse is going to give me 1 over A times D minus B times C times a matrix where A and D switch places and B and C become negative. Now, what is in this denominator is called the determinant. The whole fraction is not the determinant, just AD minus BC. And so, when you come to class tomorrow, we're going to do the in-class activity, and we're going to practice with more of this, but I want you to be comfortable with what your formula represents. If I have AD minus BC, notice that if it's in a denominator, what value can it not have? That's right, it cannot be 0. So if the determinant is 0, I don't have an inverse of that matrix. So let's look at this determinant right here. A times D would be 3 times negative 2 minus B times C is going to be negative 1 times 0. Now I get a negative 6 minus 0, which equals a negative 6. If you're brave, go ahead and pause your video and try number 2. All right, to find the determinant of this matrix, I get a negative 3 times 4 minus a negative 6 times a negative 2. Here I get negative 12 minus a positive 12, which gives me a negative 24. All right, number 3. My determinant would be 1/2 times 1/2 minus 1 times negative 1. Now I'm going to get a 1/4 minus a negative 1, which is plus 1. And I'm going to call that either 1 1/4 or 5/4. I would like you to try number 4 on your own and bring that solution to class tomorrow. All right, when we multiply something by its inverse, we should be getting the identity. And this is the identity times negative 1. To show that two things are not inverses of each other, all we're going to do is multiply them and show that they do not equal this inverse right here. Before you come to class tomorrow, I'd like you to go ahead and multiply these two together, and hopefully you get an answer that is not the identity. All right, last question for you. For what value of C does the following matrix lack an inverse? Remember what we talked about with our determinant and what it can't equal? Hopefully we remember that AD minus BC cannot equal 0. So in this matrix right here, 5 times 8 minus 4 times C cannot equal 0. 5 times 8 is 40. Let's subtract that and move it to the other side. Divide both sides by negative 4, and C cannot equal 10. If C equals 10, my determinant will be 0, and my inverse would not exist. I wouldn't have an inverse for that matrix. All right, please bring in those questions I asked for earlier at the beginning of class tomorrow. I'll see you then.